Cool. Now we get to work on Vulkan, right? So let's pull up Vulkan docs, and let's just try to get some simple compute done, right? Let's try to get a map mole done. Vulkan docs, navigation. Okay, it's cool. I should probably get started on creating the C++ project because I'm going to be using C++ for this. I don't think I'll be using another language. So main.cpp. Cool. Just include. Let's just get hello world up and running, and then we go from there, right? So int main, and then I'm gonna see out hello Vulkan. We're not using Vulkan yet. This is just world. And then we're gonna end the line, right? So, oh, and then don't forget to return 0. We gotta, and then we're gonna use a make file for building. Oh, main.cpp -o, and then we're gonna call this. I'm just gonna give it an 8 out. Cool. So if I make, cool, we have hello world working. Cool. Now we need to get started with Vulkan. Where is compute? I need to figure out how to do compute allocations in Vulkan. So what we need to do here is effectively figure out. Oh, spur 5. What is spur 5? Oh, GLSL. Okay, nonsense. Cool. Okay, hold on. Vulkan compute. Getting started with Vulkan compute acceleration. There we go. Thank you, Cronus Group. New Vulkan compute chapter for vulkantutorial.com. Ah! Vulkantutorial.com. Where is compute? Where can I find compute? Okay, hold on. Tutorial structure. Vulkan for. I want to do a map mole. Where can I find how to do a map mole? I just need to figure out how to do a matrix multiply. Drawing a triangle. API concepts. Yes, you set up memory and then you tell it to do stuff on the memory. Development environments. You need to install a whole bunch of stuff. Okay. These instructions aimed at Ubuntu. Cool. Okay, we will do the sudo apt installs necessary. I think I already have these installed because I was experimenting with Vulkan before. Yeah. And then we're going to install libvulkan dev. Cool. Yeah. Oh, we actually are installing it. Oh, probably because it's updating. Right. So, I mean, okay. So, the plan, right? The plan is to effectively take installs the standard validation and Spotify tools. Yep. Cool. You know, eventually I should probably switch Vulkan validation. Vulkan validation dash. Okay. Sure. Vulkan is platform agnostic, and so we need glfw to create a window. I don't care about creating a window. I just want to do compute. Vulkan SD. Okay, hold on. Compute shader, there we go. Introduction, yes, bonus chapter. Vulkan pipeline, yeah, cool. Here's a screenshot. Oh, they're doing particle simulation. Okay, so what they're starting with is particle simulation. And then from there, what we need to do is we need to figure out how to get it to do actual Vulkan stuff, right? So, in essence, what I have to do is, yeah. Hold on. Storing images and doing stuff. Compute queues. Okay, I don't actually understand Vulkan well enough. I just want to do map moles, right? Like, that's the goal. Like, get it in, do a compute, and then pull it out. Computes. Okay. Do they require us to... This bonus chapter is compute shaders. Yeah, okay, so what we need is... Okay, so what we need is effectively to figure out how this actually works, right? So we have to do stuff with yeah, pipeline. So okay, hold on. What an example is? It wants us to have a window. Because I don't want to make this neural network thing CUDA. I want to use Vulkan so it's like independent. Compute shader code shader slash. Yeah, it assumes we've done everything else before. Dang. Okay. Vulkan compute shader. Vulkan guide. Yes, I know how that works. The GPU compute model. Yes, you have a work group. Okay. So we effectively pass over memory and then we tell it to execute. Like I know how that works, right? But like we need to figure out Vulkan compute. A micro Vulkan compute pipeline. UVK compute. Oh, mu. Ah, micro, yes. Vulkan is great. And it's a straightforward Vulkan compute. So you clone it, you move it in, and then why is this making for Android? Oh, okay, cool. CMake build. What? Well, what is this trying to do? Is a micro Vulkan compute pipeline collection of compute shaders for benchmarking. Oh. Hold on. Vulkan. Oh my god, this is. Hey, it's 5 years old, but that'll probably still work. It's just, oh, 6 months old, they updated the benchmarks. So it's still getting updates. It's just. Dang. Okay. That is unfortunate. That is very unfortunate. Okay. So, what I need to figure out here, right, is effectively how can I make it so that. Okay, hold on. Okay, so what do I want to do here? Because I just want to be able to do compute, right? So the goal is to be able to do compute. Okay, hold on. Let's start from the start of Vulkan Guide. Home. Welcome to Vulkan Guide. We will learn. Do be civil while commenting. GPU driven render. Okay, so let's edit the stream title to change that where I'm going to. It's going to be learning Vulkan until I can. You know what? Nah, we're going to start with doing actual rendering first. End stage after tutorial. Oh, introduction to Vulkan. Yes, let's just follow Vulkan guide. When to use Vulkan. Yeah, we're doing GPU compute. Yeah, cross platform. Yeah, Vulkan's great. Vulkan render flow. Okay. Main objects and their use. VK instance, the Vulkan context used to access drivers. So it's an instance of, say, Vulkan running throughout the thing, right? So hold on, let me just change the stream title to just be like learning Vulkan. Yeah, I'm just gonna set it to be learning Vulkan, right? And then I'm gonna change this up here, and I'm just gonna be editing it to the plan. Learn Vulkan. Learn Vulkan so that I can do this later, right? So I'm gonna learn Vulkan until I can do this later. Okay, cool. Amazing. So now I have to. I'm just gonna go through the Vulkan tutorial, right? So I should probably have this in the description. Yeah, whatever. Okay, so VK device is a GPU, right? So hold on, I'm gonna make this into a draw.io so I can actually understand what is going on, right? Google Drive, authorize my account, continue, cool. And so we're gonna continue. Yeah, it's create new diagram. Vulkan combined. Blank diagram, create, save, cool. Now, okay, cool. So, gonna start. This is VK instance. This is the doorway to do anything with Vulkan, right? And so on here, we have our code, and it obviously talks to it. And then from there, what we do is we go out and we have our GPU, right? So we have our GPU over here, and VK instance. It will access it, but we will get to that at some point. Let me now go ahead and close Vulkan dash tutorial. Oh, this is VK guide. Which one's? Okay, hold on. Based on the Vulkan tutorial by... Okay, this isn't official. We want to be using... No, this is... Hold on. Sure. Hold on. Who was this made by? In progress Vulkan guide. Vulkan guide. Did we focus on game rendering? Yep. Okay, you know what? This is... It's going to be good. Close the rest of this. Cool. Vulkan render flow. Right. VK physical device. It's a GPU. Okay. VK... What's the capitalization here? It's lowercase k. Physical device. That's a GPU. Lowercase k for VK instance. I'm going to have this be big, and I'm going to put the text at the top, because I know we're going to have to do stuff on the GPU side. So, from here, style, line, dash line. Yes. Yes, this is a portal into the GPU. Cool. Then, VK buffer is just a chunk of memory. Cool. VK buffer. This is just a chunk of memory. Chunk of GPU memory. Cool. And I'm just going to leave that in the GPU because that's where it is. Right. Cool. Amazing. So what I need to do at this point is okay. VK image is just a texture. Okay. VK image. Texture. Cool. And I assume this exists on the GPU. Yeah, texture you can read it to and write from. Yeah, it exists on the GPU. VK pipeline holds the state of the GPU needed to draw. Shaders, rasterization options. Okay. So VK pipeline is just everything we're trying to do, right? So everything we're trying to do is the VK pipeline. So what we're going to do here is we're going to have VK pipeline. And this just contains everything we want to do. Cool. I'm going to make this bigger and move the text to the top. And this contains stuff like actions, right? So tasks. Cool. And I assume these call on VK buffers and VK images. So these call on VK buffers and VK images. Cool. These call on both. Amazing. Then render path, frame buffer. Only using legacy VK guide, so we don't care about that. That's also only using legacy VK guide. Command buffer. Wait, the pipeline contains command buffer? Yeah, it looks like. Okay. Pipeline contains the command buffer. VK command buffer. VK, gotta keep the capitalization. Command buffer. Right, so VK pipeline contains the VK command buffer. And then from there, what we need to do is VKQ execution port set of queues. Command buffers is submitted by. Okay, so the command buffer is part of a queue. Sure. Okay, center back. Center back. Oh wait, no, hold on. This center back. This center back. Cool. There we go. Text at the top. So this is a VK queue, and it contains just VK command buffer is just a buffer with commands, and VKQ is just a queue of commands. Okay, sure. Descriptor set is it's just a binding information. Okay, so this is a VK descriptor set. Cool. Amazing. And then swap chain. What? It's swap chain KHR is holds the images to the screen. Allows me to render things in a visible window. Sure. Render loop. Okay. I'm just gonna go on to project layout. This is okay. Hold on. Let me go to this Vulkan tutorial, and let's go about it from there. Cool. I got what I wanted from that one. Development environment. We're on Linux. Right? Linux. Vulkan packages. Yup. GLFW. We have to install GLFW. Yes. And then unlike Vulkan does not include a library for linear algebra. Okay, well. Sure. I wanted to do linear algebra, but sure. Amazing. Shader compiler. We need a program to execute shaders, yeah. So, GLSL lang validator and GLSLC. Ladder is familiar. So, okay, so we'll go with GLSLC. Download Google. Okay. Release Linux. GCC. And where are we? Okay, hold on. Cancel that real quick. Where are we putting it? We have to put it in user local bin. Okay. Okay, let me download this. And let me go to here. And then neural network Vulkan. Save. That's not an executable, so now I have to do is I have to figure out how this works. Amazing, great success. But yeah, so now I have to figure out how exactly I get this to work. So we wait for the gigabyte to download, and then from there, what we do is we have to go ahead and figure out how we get this to run and whatnot. Because the goal, okay, so obviously it wants us to go through drawing a triangle, and obviously this requires me to understand Vulkan, right? Because the goal to in order to run a neural net, I need to understand how Vulkan works so that I can do a compute shader in Vulkan so that I can actually run the neural net. I know Vulkan is meant for graphics, but like, I don't want to use OpenCL, right? Vulkan is just good. Okay, hold on. Install it. Let me extract it because it's clearly there. It's preparing the extraction. Oh, okay. This is... not an archive. Let me close the file folder then. Or not. Oh, it is reading. Okay, hold on. I have no clue what's going on. I have no clue what's going on. Oh my god. 4.5 gigs. Bin. GLSLC. We just have to copy this to... Okay. On Fedora to use that. Okay, hold on. Let me open this in terminal. We're gonna move GLSLC. Okay, hold on. This is sudo move to /user local bin. deactivate cd mounted space neural network Vulkan glslc. Yes, it works. We're going to remove that because all we care about is glslc, I think. Cool. Amazing. Now we need to set up the make files. Cool. Create a new directory, sure. And then insert it, and then don't worry about it. Sure. Amazing. We're just gonna paste it in, and then don't worry about it. Obviously, we definition of main, but we're gonna leave it like that, right? So we have stuff here. Then we have a make file. So hold on. Next we write a make file. Cool. Cool. So we're going to use C++17. Sure. And obviously it's all going to be optimized. But then linker flags. And then we have to install a bunch of libraries. We're gonna install, okay, yep, it's 900 kilobytes. Cool, we're gonna install these libraries. Yep, thank you very much. Have a good day. And so, yep. And then we're just gonna G++ based on these variables. Make. Sure. I'm just gonna set these up like so that I can actually use them here. There we go. Undefined reference to GLFW. We can't use GLFW here. Cool. Amazing. So what I need to figure out here is how do I get it to use GLFW, right? So, hold on. Right, so we have this going on here. And then what I need to figure out here is I need to use GLFW. Wait. GLFW3. Running a make should result in that. Okay. Why does this not work? Hold on. Where's the... Okay, hold on. We have GLFW here. What is GLFW in it? Okay, hold on. Let me go to definition here. Okay, so we can find it. glfw.h, yeah, it's a C file that we're including here. Obviously, we're not using Windows. Cool. So we can't, that does exist. Okay. Undefined reference to GLFW init. But we literally go to definition there. Huh? Hold on. We'll use GLFW. Wait, that's a header file. Where's the hold on, where is the actual yeah, we have a bunch of the flags. Cool. By running the make file. Okay, rename that to Vulkan test. Okay, hold on. And the make file, we're gonna get the make file, and we're gonna rename it to, instead of all, I'm gonna call this Vulkan test. Make Vulkan test. Okay, hold on. Undefined reference to GLFW init. Where is the expectation for where it should belong? Hold on. GLSLC. Yeah, okay. We just need GLSLC. Where is... Okay, hold on. Let's go to the definition of GLFW3.h. Its user include GLFW, GLFL. Okay. cd/user include no GL GLFW. There's only the header files here. This makes sense. This makes sense. We need to get the actual non-header files, right? So we have to get it, and we have to get the non-header files to go in here. So, amazing. Why is this not importing the non-header files? GLFW. Yes, this we know this works. Documentation. Example code. Yeah, so you have this stuff here. zlib, yep. Getting started. We include it. Yeah. How do I know that it actually... Yeah, okay, cool. I understand the creating window stuff. How do I get the non-header file? Introduction. Hold on. Yes, GLFW 3.4 is exactly what I have. What is in here? We have SRC, GL. Okay, not here. It has CMake. It has what? Include GLFW. Hold on. Development environment. We have all of this. That's on Mac. Hold on. That's going on Mac. So that's Windows. We're on Linux. We have GLFW. It supports everything, but it abstracts away platform, whatever. I don't care. This should just work. Yeah, GLFW 3 is on the latest version, 3.3. Sure. Where lib glfw3-dev. It's just a package containing header files. Can't install it. Okay, you know what? I'm just going to copy this into Gemini, and we'll see what Gemini does. We'll just see how Gemini does stuff. I did a... Hold on, where is this? It's still... Cool. It's thinking people have reached this problem before, so what we have to do... Oh, there we go. You're not using... Do I do that? I'll paste in my make file. And then here is my make file. Cool. And then now it will go ahead and solve this problem for me. Amazing. So Oh my god, it's thinking. Oh! Seriously? Okay, hold on. Sure. These things have to be over here. There we go! Hey, it's making a Vulkan window that's not rendering anything. Cool. Amazing. Now we go back to the tutorial. So, cool. So there's our thing there. And then we run make. This is good. Next, we're going to have test and clean. And then that's good. We're gonna have a test and clean. Dot phony test clean. Sure. Huh. Hold on. We have that. Let me comment those lines out and then make file 8. Missing separator. What is... Okay, hold on. We go back to AI here. What is the problem with this make file? A good friend, Gemini. It will help us figure out what is the problem with this make file. It's thinking, examining, it's thinking a lot. Amazing. Break it down step by step. Let's go, Gemini. A good friend. Robust and standard order. This is like... That's not what I care about, though. It doesn't matter. Those 5 variables, I don't care. Vulkan test. Yeah, okay, this should just work. Number 10, missing separator. What? Oh my god. It should be a tab instead of a bunch of spaces. There we go. There we go. Cool. Okay, I'm just gonna save that and I'm gonna close this one. Cool. One tab. Cool. So, now what I need to do is I need to figure out... Make test. Should... Yep, it should run it up. Oh, this is a template. Okay. Drawing a triangle. Okay. Yeah, and I'm just gonna call it learning Vulkan. I'm gonna and Vulkan into learning Vulkan slash. Cool. Vulkan to first triangle. Cool. So we have first triangle. Wide. Oh. Cool. And I'm just gonna rename the output instead of Vulkan test. I shall call it BIW. Cool. I'm gonna call this instead of Vulkan test. I'm just gonna call it something along the lines of first triangle. Cool. First triangle dot slash first triangle. Cool. So the goal for tonight is I want to make the first triangle tonight. You know what? You know what? I'm editing the plan. I'm gonna take the plan, rename it. Not rename it. I need to do properties here. The plan. Get the first triangle rendered. Cool. I'm gonna make that a little bit bigger. I'm gonna render my first triangle. That's the goal. Rendering my first triangle on Vulkan. Yeah. So amazing. Base code, general structure. Okay. It was starting from scratch with the following code. Okay. So let's this is our main dot thing. Okay. So first we include the Vulkan header from Lunar GSDK. Standard accept an IO stream. Yeah, okay, those are all standards. Cool. C standard lib. Yup. Program is wrapped into a class where we'll store the Vulkan objects. Sure, object oriented. And we'll call it Vulkan. And once it's prepared, we'll enter the main loop. Cool. And we'll throw an error. Just like each chunk of memory allocated malloc requires a call to free, every Vulkan object needs to be explicitly destroyed when we no longer need it. Okay. In C++, it's possible to perform automatic resource management using RAII. Resource acquisition is initialization. Okay, sure. Or smart pointers, except they've chosen to be explicit. Okay. Yeah, that makes sense. Is just be explicit. Cool. Now, what I need to do from here is Vulkan. Okay, so instead of starting from including just Vulkan, we're going to include glfw3.h. And so glfw will automatically load Vulkan within it. Okay, cool. And so in run, we're going to do an init window. Add init window. Do we have to manually? Oh, yeah, okay. It has a private. Okay, cool. Void init window. Okay, so we're going to initialize the window. Then we're going to boot up Vulkan and do all of that. Okay, that makes sense. The very first call should be to glfw init. Okay, cool. In init window, we're going to do glfw init. So we're going to initialize glfw. And so handling resize windows. Okay. And then because glfw meant we have to tell it to not do OpenGL. Okay. So then we do glfw window hint. And so the hint is glfw is underscore, yeah, underscore client API. And we're going to have it as a value. And the value is going to be glfw no API. Sure. Vulkan. Okay. glfw no API. Obviously, need the thing. I'm just gonna comment the code, right? Initialize glfw. And then here we're telling it. I'm gonna zoom in a little bit. There we go. To not use OpenGL. Cool. And then, we're just going to turn off resizing. Okay. glfw resizable. glfw resizable. I'm going to change this to glfw false. Cool. To not allow resizing. Cool. And now we actually create the window. Okay. Oh, add a... Oh, it's just going to be a private class member here. And we're going to have GLFW window pointer, and this is just going to be a window. Oh, semicolon. Okay, hold on. This is... Let me move the public under the private, because this is the way I like my code to be structured. And then obviously we don't need the private keyword here. We have our stuff. And then private windows. And then here it's just window equals glfw dot... What? Oh, it's just glfw create window. Width and height 800 by 600. Sure, I assume this just makes the math easier later. So 800 by 600. Title, it's a child pointer. First Vulkan triangle. I assume this doesn't actually matter that much. GLFW monitor. Oh, we just have null pointers to both of these. Sure. Ah, I love null pointer. The... What is it? $1 trillion mistake? My favorite. My favorite. I love $1 trillion mistakes. Null pointer is my favorite thing to work with. So, cool. And so... Oh, yeah, use constants. I'm just going to do a... above the definition. Okay, they want it to be global. I'm just going to do a define. Define width to be 800. Define height to be 600. And I'm just going to use defines instead of like global variables, because I don't want to... I just want that to work at comp time, not at runtime. Cool. And that should be us initting the window. Yep. Yep, there's our init window. Nice. And in main loop, we have to do polling of the window. While not glfw window should close this window. Yep. Then we need to do glfw poll events. So if we don't close the window, we just keep polling. Yep, makes sense. And then clean up. Oh, we just glfw destroy window. glfw destroy window. This window. I know they just use window, but that feels wrong. glfw terminate. Nice. And so that just closes off glfw. So then we don't have to access our window anymore. That makes sense. That makes sense. Cool. And this just makes a window now. A window with titled first Vulkan triangle that's made and doesn't do anything. It's just transparent. Cool. Nice. We've made a window. That's pretty easy. I should probably... You know what? That feels like a... That feels like a tweet. You know what? I'm gonna make a tweet out of this. I'm gonna take a screenshot and I'm just gonna turn this into a tweet, okay? Screenshot taken. And I'm gonna make a tweet out of this, which is first Vulkan, my first window. Yep, cool. Amazing. Now I get back to theoretically being a good streamer to 0 viewers. Amazing. Yep. Now let's create the first Vulkan object. Instance. Init Vulkan. Oh, we gotta create an instance of Vulkan. This makes sense. So it's just create VK create instance. Hold on. Fill in a bunch of information. What is this trying to get us to? GLW extensions. Yeah, okay, cool. So it is trying to get us to do a whole bunch of different stuff. Okay, so we need a VK instance, and it's just called instance. Sure. Cool. And then we have to create app info. Okay. VK application app application info, which is a struct app info. I assume this is needed for the create info. Yup, it's needed for the create info. This makes sense. I'm gonna zoom in a little bit more. Cool. Is this in create innocent? Wait, hold on. What function is this in? Oh, it's just a new function here. Okay, create. Okay, I'll have it above init Vulkan because this is where it's needed. It's gonna be a void. Yep, void create instance. Right, so you have application info, app info dot s type is vk structure type application info. vk structure type application info, app info dot p. Okay, this is effectively just like taking up all the code and bringing it over. So this is just me learning how this works and how all of that happens. Hello. No, this. Whatever. Triangle. If it crashes, it crashes, whatever. App info dot application version. And I assume. Okay. VK make version 0 0 1. We're on version 0.0.0.1. And then app info dot the engine name, and that's just going to be a very nice no engine. Sure. Oh, I assume it's for debug information. Yeah, okay. Engine version. Yank that. We're on 0.0.1, because of course we are. And then app info dot API version. VK API version. Let's just assume Vulkan 1.3. Yes. Okay. Vulkan requires us to explicitly specify the S-type member. Yep. So this is also one of many structs with a p-next member that can point to extension information in the future. We're using validation here to leave it as null point. Okay, so we don't care about the next iteration. We're just kind of continuing to do this. Cool. A lot of information in Vulkan is passed through structs instead of function parameters. Yeah, makes sense. And then instance create info. VK instance create info, which is a struct. Create info. Cool. And so, S type, okay. Create info dot S type, and that's just going to be VK structure type instance create. Sure. I have to manually type this out. Okay. VK structure type instance create info, and then create info dot p application info. Yep. And that's just going to be a reference to app info. Wait, hold on. Okay, I assume they know what they're doing. Cool. Why are we doing GLW? The first two parameters are straightforward. And then we're feeding in enable extension count. Oh, so like the 22 extensions in the GLW. Okay. Checks out. Uint 32. Sure. Why not just use unsigned? Okay, sure. GL extension shun count. Yep. And so we have the GLW extension count. That's going to be 0. Const char pointer. Oh, char double pointer. Oh, it's a list of pointers to extensions. Sure. So it's a pointer to GLFW extensions. GLFW extensions. And that's going to be equal to GLFW get required instance extensions. And it's going to be GLFW extensions. Sure, so we're going to assume no extensions. Oh, it's a reference to an integer. Extension count. Cool. Why is it highlighting that? It knows I want that. Why? Okay, fair enough. And then we include this in create info dot enable extension count equals GLFW extensions count, and then create info dot p. What is this? Pointer enabled extension names is GLFW extensions. Sure. PP for pointer to pointer. Sure. And then the last term is instructed term global validation layers to enable. Okay, sure. Create info dot enabled layers count equals. Okay, we're not including any layers. And then nice. It's just, yep, VK result equal VK result equals this, and it's a reference to this instance. Yep. An allocator? Nah, we don't have an allocator here. We use null pointer instead of an allocator. And then for the creation info, what we do is we have is a reference. Yep, it's a reference to create info. Cool. And so the general pattern of object creation is pointed to the struct of the creation info, an allocator callbacks, so we're just going to use null pointer, okay? And a pointer to the variable to store the new object. Okay, so these are all voids that they take in the info, some allocator if you're doing an allocator, and then instance. Sure. Well, the handle was stored in the VK instance class member, and they all return VK result as either success or an error. To check if the instance was created successfully, we don't need store result, and can use a check for the success value instead. Okay. Oh, we don't need, okay. I am storing the result, however. Because that just feels better. Result not equal to VK. If it's not VK success, throw standard runtime error. Yep. Failed to make instance. I know the word is create, but like whatever. I'll change it to create. I'll change this to create. Cool. Failed to create instance. Amazing. If using macOS, I don't care. I'm not using macOS. Oh my god. Okay, Vulkan's crazy. VK error extension. If you look at this documentation, one of the possible error codes is extension not present. Okay, try list this. Okay. What are we trying to do? hold on. Should like to provide details as a challenge. Check if all the extensions including the supported extensions list. Okay. I don't care. I'm just gonna assume that it works. And then clean up. VK. Hold on. VK destroy. Instance? VK destroy instance. Yeah, okay, we're fine. And so it's instance and a null pointer. I love having null pointers. Cool. Amazing. And so, yep, we have all this. Please tell me that this still works. Oh, wait, hold on. Okay, it doesn't kill that immediately, and it actually has a runtime. And we interrupted it, and it's good. Nice. On to validation layers. What are validation layers? Minimal driver overhead in one of the manifestations has very little error checking. Okay, sure. Yeah, okay, less error checking, that's fine by me. And so, oh, welcome back. Amazing. Yeah, and so less error checking, I can just assume that it's good. It's easy to make small mistakes. Yeah. Cool. Implementation of a function in diagnostic validation layer. Okay. Yeah. So here's an example of what is. Okay, so just log a bunch of this stuff, right? So if you feed it a null pointer, just like continue logging. Okay, cool. Validation layers can be freely stacked, include all debugging functionality. Test them, simply enable validation layers with debug them, completely disable them for release, which gives you the best of worlds. Vulkan doesn't have any validation, but Lunar G Vulkan SDK. Sure. We'll enable standard diagnostics layer provided by Vulkan, just like the extensions. The validation layer needs to be enabled by specifying their name. Okay. Sure. I'm just gonna copy this macro, because this is... Oh, you are not back. Unfortunate. Goodbye. Yeah. So effectively, we're going to copy the macro, and I'm just going to paste it in here. And so, yeah. Oh, we have to include vector. I love vector. We're going to include vector. Amazing. So now what we're going to go from here is we're just going to keep following it, right? So, sure, we'll have validation layers in here for the first time, and from there we'll move on, right? So, if, yeah, so if enable validation layers or not, and so we're going to have a bool check validation layer support. We'll add a new function. Sure. And I assume it's just going to be a private function in here. So I'm just going to... I'll add it in here. This is just like... This is a thing that... I'll put it before create instance, right? Because I assume we use it in create instance. Check validation layer support. Hold on, let me tab these in, because this is going to ruin me if I don't. And then, yeah. So we have checking for validation layers. Okay, so let me go back to my draw.io where I actually try to figure this out. Hold on. Let me go back here. Open existing diagram. I'm just trying to open the recent one. Vulkan combined. Okay, so what is the what are we trying to do here? Okay, so we've yet to get to this point yet. We've just kind of been setting up the VK instance. Yeah, okay. So we have just kind of been setting up the VK instance, and I'm back to 2 viewers. Unfortunate. Okay, so yeah, we just kind of been setting up the VK instance, and we need to... Yeah, we have checked that out, and so yeah, we just need to keep going here. And so for... Now check if all the layers in validation that exist in the available layers. You may include the C string for string compare. Cool. Okay, where am I putting this code? In check validation layer support. Okay. So we do it here. Cool, amazing. So we just kind of keep going. For each thing. Yep, okay, so if not layer... Hold on, what is going on here? Yeah, so if any of these layers are not found, we return false. Otherwise, we return true. And that's the indentation we want. Yup, we have to include C string. And so include, oh, sorry, string compare. Oh, C string. Yeah, I have to include C string. C string, amazing. And also let me add a space here because that's going to annoy me if I don't. Cool. Amazing. So we have the validation layer support. If not layer found, return false, else return true. Yep, okay, cool. And then create instance. If enable validation layers, and if we're trying to enable validation layers but we don't support them, just yeah. That checks out. That checks out. Okay, how do I run this in debug mode? That's the important question. Okay, whatever. And then yeah, okay. Okay, hold on. What is going on here? If def n debug. Okay, hold on. What are we setting up here? O2 GLFW. Okay, hold on. G++ flags for debug. That's G. Okay. Yeah, so in essence, what I have to do is use G with -O. Hold on. It is enabled by default when compiling with authorizations, debug information. Okay, you know what? I don't care enough to do that. I am going to continue following the tutorial peacefully and ignore the whole validation layers stuff. Now the program, sure. Modify VK instance create info struct to include validation names if they are enabled. Okay. VK instance create info struct. VK instance create info struct. And what we're going to do is we're going to enable layer count. Okay. If we're enabling validation layers, what we do is enable layer count is just the length of validation layers, and the layer names is validation layers data. Otherwise, we just set it to 0. And then, okay. And then we move that in there, I assume. Yeah. Sure. Ever return a VK error layer not present error, but make sure you run. Yep, let's run the program. Yeah, it's working just fine. Cool. Message callback. Okay, what is the goal here? The goal here is to try to get a callback of the message. And so, yeah. So, standard vector construct equals get. Hold on. It will print debug messages to standard output by default, and we can handle them ourselves by providing explicit callback. This will allow you to decide which kind of message you like to see, because not else of them are errors, and if you don't care, you don't care. So we had to. So get required extensions. Okay, sure. So in here, above here, before create instance, we're gonna have a function that gets the required extensions. Sure. Amazing. And so it just pushes it back to the extensions list if we have it. Otherwise, yeah. Next, in create instance, GLFW extensions. What type of extensions are we trying to deal with here? Hold on. We need to use this in create instance. Auto extensions equals get required extensions. Yes. Okay, we'll set this to auto. Extensions equals get required extensions. Create info dot. Okay. Sure. And then we just have the size of it and the data. Okay, sure. And then extensions. Okay, then it's just all of our extensions. Extensions. There we go. Cool. So we just have all of our extensions and then we create it. Run the program to make sure it doesn't fail. Cool. Make test. Yep, it works. Amazing. So now we just have to keep going. So run the program. Debug callback function. What is this? Static VK API attribute VK bool32 VK API called debug callback. Write signature for Vulkan to call it. Okay. Huh? Hold on. So, and it takes in a bunch of stuff. And then validation layer, P callback message data, P message, VK false. If it's more than a warning, then we do it. Set up debug messenger. Debug callback. Okay, hold on. All this to debug the Vulkan? Sure. Strange thing to do to get to try to debug the Vulkan, but like, sure, makes sense. Yeah. Amazing. So, what I need to do here. Okay, hold on. I would have this function, I assume, outside of the class? No, it's part of the application. It'll just be a private function here. I'll do this before. Yeah, the creating of. Nah. Check validation layer support. Yeah. Get required extensions. I'll just do it underneath. I'll do it underneath. This is where we put all of our stuff, right? So. Oh my god. Okay, I will have all of these one layer tabs. And I'm gonna do something like that. Yeah. No, I want to do something like that. There we go. Now it's nice code style. Validation, and we return false. Cool. The edit. Okay, so VK Devo is using message severity, verbose bit text. Wait, hold on. The first parameter is severity. Yep. Okay. So if it's very severe, we want to print it. Otherwise, we don't, and then we just have that as an if statement. If message severity. Okay. I'm just gonna ignore that. I'm just gonna print everything. Sure. P callback data. Okay. P message. P objects and object count. Okay. So it'll only print the stuff that it cares about. Cool. This is telling Vulkan about the callback function. So even a debug callback is managed with a handle that needs to be explicitly discrete. Okay, yeah. Put a debug messenger. Add as a class member for this handle. Right under instance. Yeah, okay. So right under instance, we're going to have a very nice vk debug utils messenger ext, and it's going to be our debug messenger. Cool, amazing. Now from here, what we need to do is, yeah, okay. So what we need to do from here is, oh, init Vulkan just set up debug messenger. Sure. Create instance init Vulkan. We're gonna create the instance. Set up debug messenger. Set up debug messenger. And we need to make that as a function, so I'll put it underneath. Sure. It's just we set up the debug messenger. Cool. Now we have to continue keep going. So fill in the structure with details about the messenger and its callback. So okay, it's just a whole bunch of info. Sure. Oh my god. Okay, so S type. This is a create info verbose ext. The severity, we're just gonna, I guess that looks like enable all of them. Message types, all of them. User callback, it's the debug callback, and user data is null pointer. Sure. Create info, yep. And then from here, what we need to do is we just need to continue, right? So we just need to take the message severity field and we just need to be able to, combine it all together, right? So message severity field allows you to do stuff, I assume. Hold on. I am going kind of insane. I am an insane individual. I'm going insane. So create debug utils mess. Making another function. Okay. Create debug utils messenger. I'll put it above the setup debug messenger. This feels like this should be multiple files at some point, but I guess we're gonna stick with one file for this. Okay, func is the get proc add, and then we just this is just a thing to. So if the hold on, if create what? Now call this function to check if it's created. Huh? Hold on. If create debug utils messenger ext. Yeah, so the function we just created, debug utils messenger ext, is not success, throw an error. Ah, here. Okay. Instance create info. Sure. If we failed to create it, throw an error. That makes sense. And so obviously we're writing into a debug messenger. So this is the thing. Proc add instance vk. Oh, this is just telling us to create it. Okay. And the second, it's optional allocated, whatever. So the vk debug utils messenger ext also needs to be cleaned up with a call to destroy. So create a proxy for it. So this is a function that all it does destroy. I'm gonna put that above cleanup. Okay, so it's the proxy function that takes in some stuff and calls the vk destroy debug utils messenger. And then in cleanup, I assume, if enable validation layers, we destroy our debug messenger utils. Cool. Amazing. Now we've added debugging. Hold on, let me make sure it still compiles. Okay, make test. Validation layers requested but not available. Unfortunate. Enable, okay. Hold on. Let me look at the C++ code. Hold on. Let me copy and see if this compiles, and it's see if it's 2.cpp. And we're just going to compile 2.cpp. Make test. Validation layers requested but not available. Huh. Does my graphic... No, I have a 4060. It should support this, right? I think my 4060 does, in fact, support all of this. Hold on. Okay. Oh, I am... Oh, I am so far away from the first triangle. Oh my god. Okay, I'm gonna finish setup today, and then I'm going to go and deal with that, because oh my god. Okay, let's go Vulkan API 1.1. Okay, hold on. Okay. Okay. So I know the problem is not with my code, but I am going to try to make it work, because clearly Vulkan does work on my machine, right? VK... Validation layers... Check validation layer support. Okay. Problem is that there's something going on with check validation layer support. Okay. If not layer found, we're just going to see out the layer name, and then we're going to end line. VK layer Chronos validation. Huh? Yep. Hold on. Okay, so we have check validation layer support. We have available layers. Layer count. Layer count. Hold on. Enumerate instance layer properties. For every... Hold on. Pipe. Layer properties dot layer name. And what layers are actually enabled here? VK layer valve steam fossilize overlay fossilize Optimus device select Intel, so, and that's the one that doesn't work. VK layer Chronos validation. Let's go to the docs. Let's figure out what this is. This is explicit API. Yeah, okay. Figuring the validation layer. Hold on. What caused this to not be available? So Vulkan validation player is either not installed, not configured, or doing stuff. Okay, so I just had to Okay, cool. So this implies that I have to go back to the dev environment and figure out what doesn't work, right? So Linux Vulkan packages. I have Vulkan tools. Okay, hold on. Let's run Vulkan info. Okay. I have everything except for texture compression, capture and multi-device, sure. I don't have protected memory or storage input output 16. And there's some atomics I don't have. Sure. Okay, there's just... Okay, that's actually a lot. Oh my god. Okay, this has a lot of info. VK cube. Cool, we have a nice cube. Amazing. Lib Vulkan dev. Already installed in newest version. Ah, Vulkan utility libraries dev replaces it. Ah! So instead of validation layers. Oh, that's what the... Vulkan utility dash libraries. Cool. So we have that. Amazing. Now we just have to keep... Okay. Cool. Now it's installed. Oh, I had to... Maybe I had to close this. Under deactivate. We're going to go to mounted space. What did I call the folder again? Hold on. Learning Vulkan. There we go. We'll go to first triangle. Validation layer requested. App install validation. Okay, hold on. So it didn't actually change which ones were enabled. I still have the exact same layers enabled, right? Dang. So let me copy that and... Not... Hold on. Let's go to good friend Gemini at AI Studio, and we will figure this out. We will figure this out together. VK layer Kodos validation. Not available on my Ubuntu machine. How do I fix? And then it's going to go, it's going to think, it's going to give me an output. And it's going to be great. Yeah. And so then from there, what we do is we just have to keep going, right? We just have to... Solution. Cool. So we have to update. Oh yeah, we could just check it in Vulkan info. Warning. Code terminal received -3, skipping this driver. VK layer photos. Why is it not there? Okay, so it wasn't there. Sure. Create instance. What? It's not there. Vulkan utility drivers is already at the most recent version. Hold on. Do I have to restart my computer? Okay. Oh, it has a whole list. Ensure Vulkan is installed. Yes. Install Vulkan validation layers. Oh! Oh my god. There we go, so it does work. Okay. So I probably installed the wrong thing. Unfortunate. Sure. Cool, we're back here. Amazing, amazing. So, we keep going. So, what we have... Oh, What? Okay, hold on. Drawing a triangle, setup, validation layers. Oh, wait, it was here. Okay, then, cool. We now make sure... Yeah, now it all works. Amazing. Now let me remove the print statements in the whole check validation layer support, because... Amazing. Now we need to make a populate debug messenger create info. Wait. What? Above the setting up of the debug messenger, populate debug messenger create info. Okay. Oh, we just update the... Sure. Setup debug messenger. Yeah, okay. And then, yeah, and then we just call the populate create info on the create info. Cool. Amazing. Directly? Yeah, just directly. Oh, and we need the semicolon, of course. Cool. So, yeah, so from here, what we need to do is we can reuse this in the create instance function. So void create instance. Create instance is above here. VK instance create info equals create info, app info, VK debug. Okay, so it's just enable extensions. Oh. Okay, yeah. So for extensions here, instead of doing that, we just do this. And then, yeah, cool. And then we just bring it up. And yeah, cool. Enable layer is 0. Enable layer content and names. Pnext is debug create info. Cool. And then obviously we have that. And then we test it by just running that. Oh, there we go. Failed to set up debug messenger. Dang. Validation error. Message. This does not include VKX debug utils, but next pchain includes that. If it includes that, then... Okay, what? Copying old device 0. Failed to set up debug messenger. What? Okay, hold on. Searching for device. Check your Alright. Sure then. Our good friend. I have no clue what's going on. Alright, the model's thinking. Cool. Obviously, ton of errors. Understanding log message. Yup. The solution? Find your VK instance, create infrastructure. Okay. So this should be create instance, create infrastructure, and then locate the enable extension names. Layer names, yep. Hold on. Enabled extension counted names. Okay. Yep. Okay. So that was whoopsies. And so we're looking for init create instance. Create instance. Okay, so we do have to keep this little blurb. Cool. That was a good test to have. And there we go. We have some validation layer blurbs. And then there we go. Configuration, there's a lot more settings, but I don't care. Selecting a physical device. Oh my god. Okay. Cool. Init Vulkan. Underneath that, okay. Void pick physical device. I mean, it was running. I mean, that one was running on NVIDIA pretty well, so I just had to keep that up, right? So pick physical device. So we will start. The graphics will be stored in a VK physical device that is added as a new class member. So it'll be implicitly destroyed when VK instance is destroyed. So we don't need anything in the cleanup function. Okay, so we just have this as part of the class. Physical devices starts off as null. And when we pick the physical device, so we enumerate the physical devices. Okay, checks out. So it gets us the total number of physical devices. And then if device count is 0, then obviously we throw a runtime error. Cool. Then we just we make a vector of devices that is device count long, and we just plug them in. VK enumerate instance device count devices.data. Oh, that's just checking. Okay, sure. Because not all graphics. For that, we'll introduce a new function. Sure. Is device suitable? We return true. Okay. And then at the end of this, we're just gonna go through, and if there's a suitable device, we will use it. If not, whatever. Right, so go through. This checks out in its entirety. Yep, hold on. Yep, okay. So if there is a suitable device, we just set it to that device. Is suitable device function. Okay, so so step one, first we get the device properties from the Vulkan device. And so we get the properties and features. Cool. Right. So we have the device properties and we have the device features. More details, device memory in the next section. Logical device and queues. Cool. So what we have to do here at this point is, you know what? Okay. I'm getting a little bit tired here. So I think I'm just going to pause the stream. I'm going to stop the stream for now. Hold on. I'm just gonna add this. Make sure it still compiles, and then yeah. So I'm just gonna make sure it still compiles. I'm gonna add this return, and then I'm gonna make sure it still compiles, and I'm just gonna end the stream because this is yep, it still works. Cool. I'm just gonna end the stream here because I'm getting a little bit tired. So thank you all for watching. This stream was probably not the most interesting, but soon it will become more interesting. Thank you all for watching. I will see you all next time. Have a great day.